All right, so let's get the show started. All right. Welcome everyone to live stream number 6. Thank you guys so much for joining me today. I'm Professor Peters. Today we're talking about inequalities review. So I'm going to give you a whole complete review on how to graph inequalities, inequality, interval notation. We're going to look at compound inequalities and more. So the first thing we need to understand, guys, is how to graph an inequality. So typically I tell students whatever number that we're working with, right, from the answer, that is going to be the answer that we put in the middle of our number line. And this is where the circle, this is the number that the circle should go over. So anytime that we have a greater than sign, such as this, or even a less than sign, we're going to have an open circle. And when we have a greater than sign, we're always going to shade to the right hand side on the number line. And when it's less than, we're going to shade to the left. So with this right here, this is what our graph should look like. Open circle going to the right. Now, when we talk about interval notation, just understand that's another way to express the graph. Okay. So the first thing we need to know about interval notation is if we have a greater than or less than sign, we're going to have a parentheses around that number. So we're going to start off with 5 because this is where the graph starts, right? At 5, but 5 is not included. So this is why we have a parentheses, and then we're going to put a comma. Now, where exactly is the graph going? So when we talk about inequalities, we cannot list every single number that's greater than 5. So what we're going to do is replace it with a symbol that looks like this, and that's the infinity symbol. So we have positive infinity, and then on the negative side, we have negative infinity. So to complete the interval notation, we know that our graph starts at 5 and it's going to go all the way to infinity, all the positive numbers that are larger than 5. So when we're trying to finish off interval notation, just know that there will always be a parentheses around infinity because we can't include all of those numbers, right? There's always a parentheses around infinity. Now let's go on to the second problem. Let's see if we can pick it on up a little bit. So when we go to our second problem, it tells us that x is less than or equal to 0. So what this means, right, we're going to have a closed circle because it's or equal to. So when we have less than or equal to, greater than or equal to, we're going to have a closed circle on our graph. And like I said earlier, if we're talking about less than, that means we're going to shade to the left side of the graph. So all the numbers that are less than 0 are this way. What about the interval notation now? That's the big part. So let's write in the infinity symbols, right? When we look at this graph is coming from all the way out there from negative 1,000, negative 2,000. But because we cannot list all those numbers, we're going to substitute it with negative infinity. So we know all those negative numbers are included in the range, and we're going to go all the way down to the number line, all the way till we get to 0. Now, the difference with this for this problem and the first one is that when we have the or equal to, when we're doing interval notation, we're going to have a bracket around that number. Okay. So that's the basics of interval notation. What we're going to do now is I'm going to focus on solving some inequalities, and we're going to tie this interval notation into compound inequalities and absolute value inequalities and more. All right, so we're working with a multi-step inequality, meaning we're going to take at least 2 or more steps to solve, and we're going to graph the inequality and come up with the interval notation. So here are some important things to know. Number one, just make sure you remember that we're not going to do x minus 3. What we're going to do is distribute this 3 to x and 2. So in our first step, we should have x is greater than 4. That's what we should have after our first step. Now we combine our like terms, and after our second step, this is what we should have, right? Now we see that 6 and 4 are like terms. Now we're going to bring the 6 over to the other side of the inequality. So here goes our not our answer, but we're getting close to the answer. So negative 2x is greater than 10. Now here goes a very important lesson with inequalities. So anytime we have our x, our variable is negative, right? Negative 2x. Anytime it's negative and we divide by that negative or multiply, we have to flip our sign. So because I divide by negative 2, right, and that 2 was attached to my x, we're going to flip this sign. And instead of it saying x is greater than, we're going to have x is less than negative 5. So let's actually draw that on a number line. So we'll put 5 in the middle. This is negative. Let's make sure we number correctly. All right. So because it's less than, right, we have a open circle, and then we're shading to the left-hand side of the number line. Now, when we talk about interval notation, right, let's think. We handle interval notation like we're reading a book from left to right. So we know that all the answers from the negative hand side, right? So we're coming from negative infinity because all these answers are included. And we're coming all the way down to the number line to what number? Exactly, to negative 5. So once we get to negative 5, now we need to determine, are we going to put a parentheses or a bracket around negative 5? And we know it's going to be a parentheses because it's a greater than or less than sign. So this is how you would solve this multi-step inequality, graph it, and come up with the interval notation. Now, what I want to do with this part, we're going to switch over and I want to show you guys how to solve inequalities when we have a fraction, okay? Because that is something that I see students struggle with often. And I want to make sure that you guys know how to do that as well. And like I said, guys, if you guys are enjoying this show, I say smash the like button for us. It really helps with us getting this video out to more students who needs help. All right, so we're going to a two-step inequality right now. And the problem is this. We have 1/3 x plus 4 is greater than 11. So there's two ways to solve when we have fractions. The first thing to do, we could get rid of the fraction by multiplying it by 3. But if we multiply by 3, we have to multiply 4 and 11 by 3. So what I like to tell students is get the fraction by itself on one side. So let's subtract 4 first, all right? Because now we can have that 1/3 x by itself on one side. So after we do that now we need to get rid of our fraction. But we need to make sure we understand this negative. So remember that we have a negative because one of these numbers was negative and one was positive. So I'm going to keep the negative with my 3 so that x stays positive, okay? Just want to make sure you guys understand that. So we multiply by -3, that is gone. We're left with positive x. And then we go on the other side of the inequality and multiply by -3. But before we finish off our answer, remember earlier I said if we multiply or divide by a negative x, we have to flip the inequality. So in this problem, we didn't divide by a negative number, but we multiplied. So we have to flip this inequality sign. That rule still applies. So we have x is less than, and don't forget your negative sign because I almost did. X is less than -21. Now, let's see if we could graph this and get the interval notation. Let's go out here to the side. And just for a rule of thumb, your number line doesn't have to have 0 all the way up to -21. You could put 21 in the middle like I do, and just put at least 2 to 3 numbers next to it, right? So we'll have -21, -20, -19. And then on the other side, we'll just put -22, -23. I know students sometimes get confused because they don't know how many numbers to include in the number line. At least 2 numbers is always a safe bet. All right. So we know open circle, and if x is less than -21, that means we're shading to the left away from 0. So our graph should look something like this. Now, in terms of interval notation, our interval notation would be negative infinity all the way to -21. We look at our sign to check. We have a greater than or less than sign. So we have parentheses. If it was a less than or equal to sign, 21 would have a bracket around it instead of a parentheses. Right. So hopefully you guys are enjoying the show. What we're going to do now is I'm going to switch over to compound inequalities and we're going to take a look at how to solve these. And it gets a real tricky because it's two inequalities in one. So let's start off with our ORs, okay? And I'm going to tell you guys some key things with your OR so that you know you're doing the problems correctly. All right. So rule number one, we're solving the OR inequalities. So what we have to know is we're going to solve basically two different problems. Problem number one, inequality number two. And we know that our graph is right because our graph should be going in the opposite directions. If you have an OR inequality and the graphs are running into each other, guys, I'm sorry to say that's going to be wrong. So let's solve and let me show you guys exactly what I mean. Oops. Add 5 on both sides. 2x is greater than or equal to -6. And just real quick, see, students sometimes think they need to flip the inequality sign because 6 is negative. But let me just tell you, no, it's only if 2x was negative and then we divide it. With the constant is negative, the inequality sign does not flip. So let's divide by 2. We have x is greater than or equal to -3. All right, so that's inequality number one. Or, and let's go on to the second one. So in the second one, just pay attention, right? 10x is negative. So that means we're probably going to have to flip that inequality sign. So I add 6 on both sides. Negative 10x is greater than 50. Let's just flip the sign from now so we don't forget, because sometimes I'll even go through, do the right steps, but still get it wrong because I didn't flip my sign. So x is less than -5. So now we've solved. Let's go down to the graph and let's go down to interval notation. All right, so let's see how we're going to label this. So 2. All right, so I had a little bit of a smaller graph. So let's start off with x is greater than or equal to -3. So we know closed circle, greater than means we're going to the positive numbers to the right. All right, boom. That's number one. Number two, x is less than -5. Open circle. If it's less than, we're going to the left. So now we've graphed this, and like I said, right, both of these graphs are going the opposite way. If they were going towards each other, this is an indicator that we graphed wrong. All right. And if we didn't flip the inequality sign, we would have ended up with a graph like this. So just make sure you double check your work. Now we talk about interval notation. So with the ORs, we're going to have two interval notation separated by the word or your teacher may teach you to use this symbol that's U to be with to say in union with. It's basically saying like and or. So when we look at this first one, right, our graph is coming from negative infinity and it's going all the way up to -5, right? We look at our circle, it's open, so that means we're going to have a parentheses. Then there's a gap in between -5 and 3, right? So here goes the or. Where does the graph pick up after that? It picks up at -3. So when we're at -3 now, there's a closed circle. So with interval notation, this means we are going to have a bracket. And where is this graph going now? It's going to all the numbers that are larger than -3, and we use the positive infinity sign to represent it. And remember, always, always, always a parentheses around the infinity symbol. So these are the OR inequalities. Okay. And like I said, hope you guys are enjoying this show. If you do, smash the like button for us. or leave a comment if you guys have any questions. We'll definitely try to answer them as soon as possible. Okay, so this is the first scenario when we talk about compound inequalities. Now, what I want to do is take the time to go into the second version of compound inequalities, which is our ands. So with the and inequalities, right? Let's write the problem. Let me get down the problem first. All right, so with the and inequalities, what happens is you basically have two inequalities combined into one, right? And your answer or your x is going to be in the middle. So with these graphs, the graphs are going to run into each other. And the infinity symbol is never, never included with the and graphs. So if you have an infinity symbol with an and graph, that means your interval notation is wrong. So for students who don't like this method, you could split the inequalities into two. So what do I mean? You could cover up one and solve it like this, and then you could cover up the other one and solve. But for this video purpose, I'm going to show you guys how to just solve it together. And what I tell students is to combine your steps on both sides of the inequality, right? So we add 10 to itself, then we add it to 6, and we also add it to negative 24, right? And then bring your sign straight down. What we have left in the middle is 2x. Negative 24 plus 10 will give us negative 14. On the other side, we're going to have positive 4. All right. So now, second step, we just have to get x by itself. So the opposite of 2 times x is just dividing by 2. And the same thing I said, we have to apply dividing by 2 to both 14 and 4. So once we do this, bring your sign straight down. All we have left in the middle is x. Negative 14 divided by 2 is negative 7. 4 divided by 2 is 2. So how do we read this inequality? What this saying is that, hey, our answer, x, is greater than or equal to negative 7 and less than 2. So let's graph this real quick. All right, so let's graph this. Negative 9. All right, so label my graph, my number line by 2, just so we could squeeze this in a little bit more. So we're talking about negative 7, right? It's greater than or equal to, so I should have a closed circle. And then positive 2, which should be right here, and this is an open circle. So if x is greater than or equal to negative 7, that means we're shading towards the right. And if x is less than 2, that means we're shading towards the left. So because this graph is running towards each other, guys, that's how we know our answer is correct. Now, how exactly do we do interval notation? What I tell my students is this. Look at your answer, right? Rewrite your answer. So we're talking about negative 7 comma 2, right? Because this is where this is the range of answers. Because remember, interval notation is just a range of answers. So the range of answers is right here between 7 and negative 2, which we have. Now we need to determine parentheses versus bracket. Closed circle means we have a bracket around negative 7. Open circle means we have a parentheses around positive 2. And that is it. Okay. So hopefully you guys have been enjoying this. Like I said, we're going to go over now to the absolute value equations. I hope you guys have been enjoying the show so far and you found this real helpful. All right. So we're on to the absolute value equations, and I'm going to break this down as easy as I can for you guys. So let's get this started. All right, and just to let you guys know, this is the absolute value brackets. Okay, so when we're dealing with absolute value equations, right, we're going to have two equations, one that's positive, one that's negative. But before we get to the equations, we want to have the absolute value by itself completely. So when we look at this problem here, this absolute value is not by itself. So what do we have to do, Mr. Peters? Glad y'all asked. Your boy got you. So we're going to add 6. All right. And let's rewrite the problem. All right. So we added 6, but we've noticed that, hey, absolute value still not completely by itself. So now we're going to do the opposite of multiplication. So we're going to divide. 3 cancel out. We go on the other side, do the same thing. Now we're left with the absolute value of 2x minus 4 is less than or equal to 10. Now that it's by itself, we could start doing some magic, right? So what I'm going to do here is we're going to write the equations down, and then I'm going to do some erasing to make sure we have enough space. So now we're going to drop the brackets and write the equation. So this is equation number 1. This is the positive one. Then we're going to rewrite the same equation. And what we want to do with the second equation is flip the inequality sign, number 1. And after we flip the inequality sign, we're going to change the number from positive to negative. All right. So we flip the sign and flip the inequality sign and then change the number from positive to negative or negative to positive, vice versa. So boom, now we have our equations that we need to use to solve the inequality. So let's go back now and let's erase. Well, no, let's not erase. Let's go to the top. So in our first one, we have 2x minus 4 is less than or equal to 10. We're going to add 4 on both sides. So that gives us 2x is less than or equal to 14. When we divide by 2, our final answer is x is less than or equal to 7. All right, that's answer number 1. So now what I'm going to do is I'm going to come back over here and let's see if we can answer the second equation that's negative. All right, so let's rewrite this one. So same steps. We add 4, but just don't forget this 10 is negative. So when we combine those integers, we're going to get a different answer. Negative 6, we divide by 2. Now we have x is greater than or equal to negative 3. Okay. All right. So now let's go through and let's graph our inequalities. All right, so we have x is greater than or equal to negative 3. So we know that is a closed circle, and x is less than or equal to 7. So this is also a closed circle. So once we graph this absolute value inequality, guys, they're going to be going towards each other. And then for our interval notation, like I said, we're going to write this in the same order. So we have negative 3, and this graph goes to 7. We'll put a bracket around both of them because they both have or equal to signs. Okay. All right, guys. So we're going to take a break there, guys. Thank you guys so much for joining us with our inequalities review video. Hope you guys found this video helpful. Smash the like button on the way out for us, guys. Thank you so much for joining us today on our live stream.